And it all has to deal with how you control it, what is the control system, is it radio operated, and so on. Okay. Then this is a very good example of another one where it's a, this has probably 30 or 40 degrees of freedom. Degrees of freedom is basically how each joint moves relative to another, and you'll study that when we get back for the next class. We'll dive into what degrees of freedom are, how you can navigate, how you can generate motion, what types of joints you have. So this is an example of an underwater robot. This is a very sophisticated example. Most common ones are the ones that you use are submersible vehicles that can film underground under high pressure, and they are completely water resistant. So this is the, okay, let me show you. All of you are aware of self-driving cars, so I'm not going to go into that. This, obviously, now, you've seen humanoid robots. There's only one example that I want to give you is when you try to anthropomorphize machines or give them human form, obviously there is a complete discipline that wants to give facial features. So here is a set of companies that deal with actually giving the emotions or the expressions that you have. And this is completely an Android system. Android does not refer to your OS. Android is something that is humanoid.
But perhaps we can meet each other in person on my next visit to New York. Thank you for your time and have a great day.
So this is, there, as I said, I mean, there are amazing robots out there, but I can just go on showing you a lot of stuff, but I just wanted to give you an idea. Now, what I would encourage is, other than the course, most of you can do a lot of projects. I had, from the last time I taught robotics, we had a lot of senior projects. One of the groups, they did their own project. This is one of the groups they did their project, and this was a basic RF controlled crawling robot. They developed 3 or 4 prototypes.
Control these devices.
Guys, now we're going to have a book. So, can climb.
Aaron, you're not a
We can
problem.
go forward. So, then I can turn around.
Right, and then we had another project, which was basically the smart mirror. I don't know if you guys have.
As you can see, it's
So it basically gives you your daily schedule.
mirror, the display on the back. And if you look onto the back, you'll be able to see the display and everything that's connected to it. So this is the back of the smart mirror. As you can see, we have the black case itself surrounding the whole thing, the display.
Let me show you.
Now, one by one. What time is it? Show me the weather. Show me the weather in Bridgeport. Show me Bridgeport. Show me the map of Bridgeport. Take me to Bridgeport from Nagasaki.
So
Show me the
basically,
news.
we keep playing with that. But the idea is to have an automated system that you can walk up to in the morning. It gives you a daily schedule, everything, and so on. So the purpose of showing you all of this is because when we get into the math and science, there is a reason that we're studying this, because all of this does not happen randomly or just because it's shown that way. There is a lot of math, calculus, and programming that goes into it. And we'll start off with doing the simplest form of robots, as I spoke to you about, which is the serial robotics. So I'm going to give you the syllabus sheet. This is the prescribed book. I would recommend that you get a copy, and we will be dealing with serial robots in this. Here, pass this out, please. We have one copy. Okay. So, here, this is the, just pass this. This is the textbook that you'll see, it will come to you. And there is a prescribed book. If you look at the references, there are two prescribed books. The first one, which is the Introduction to Robotics, is a good book. And then we have one that that deals more with the programming part, which is MATLAB, and I'm going to talk to you about that when we get to the lab. Even otherwise, I'll give you a fairly decent amount of handouts, so that should be fine. We'll have assignments, we'll have few, you already have that on your, it's on the sheet, Okay. All right. Towards the end, if we have time, we'll go into programming Arduinos, right? So if you look at lab work at the bottom on the first page, so you have various simulation tools, because everything that we do in the class, we will simulate it, check the output, and then we'll have mechanical programming of actuators and sensors on an Arduino. So if you turn around, you'll see a syllabus list. Okay. The first class, I'll talk about how to represent bodies in 3D space, okay, which includes positioning, orientation, what are techniques used to define the orientation of a body. Then we'll go to different manipulator configurations, which is a certain set of standard manipulators based on how the joints and links are arranged. We'll talk about axes and frames. Then we'll go to forward and inverse kinematics. What do we mean by forward and inverse kinematics? Forward kinematics is basically what should be, let's say I want to reach XYZ in 3D space. What should be my displacement? How do I move my arm so as to get to a particular place? And it's a lot of math, okay? So if you're not comfortable with math, or especially if you're an undergraduate student and if you don't have the basic prerequisites with calculus, it's probably time, this is the week to reconsider your decision, okay? We'll go into velocity and dynamics and so on. As we move forward, then we'll finally talk about path planning. That means what kind of a trajectory should a robot take to navigate a certain space. Then we'll talk about control. Control I might touch upon briefly, because some of you might have the controls background, some of you might not. Other than that, we'll have a midterm and a final exam. We'll have assignments, obviously, and Aaron knows about it. He's got a lot of assignments. Okay, so you have the split there with your final exam. Actually, there should be a midterm exam also, so I'll give you an updated sheet, because evaluation does not include the midterm exam, but I'll change it, I will give it to you. Okay, so if you're not, especially with the labs, if you're not present in the lab, I'm not going to accept something that was done later. You'll have to finish, you'll have to be present for the lab. But lab is a couple of weeks away, because we haven't covered anything yet. Once we cover a significant ground, we'll schedule a lab, and you'll get an email on where to meet, because we'll be doing that in one of the computing labs, either 112, 113, or so on. Okay. So if you can, with the lab, I would advise you to bring your own laptop. That way you can go home and continue working on it, or you're most welcome to use the ones that we have in the lab. That is pretty much the syllabus. Obviously, we meet 2 times a week, and ideally, I would like to have it as a theory and lab, but we'll see depending upon how much is covered, because there's no point going to the lab unless we have done something new that we can implement. Okay. Anything else that you might have a question about the course? Course-wise. graduate assistant is, for this course, is Franklin, okay? So if you have any questions or if you want to email, if it's trivial stuff, I don't have a syllabus sheet, can you give me a handout again? You can contact him. But if you like to see me, my office hours are on there. Friday is a very good time. Anytime on Friday is good time to stop by my office. Or if you want to just talk, just send me an email anytime. Most of the lectures will be recorded, and I'm going to share it with you guys. If you are somebody, I know there were a few requests. I mean, we'll have a few more people because I haven't signed in some people who are undergraduate unless they have the background. Or if you are somebody who's just proctoring, who's not registered for the course, let Franklin know so that we know, have an exact count of how many students are in here. So on your way out, just make sure that if you are somebody who's not registered and is just proctoring the course, let him know, okay? Thank you. Okay, so,
We didn't sign that.
you didn't sign that. If anybody who hasn't signed that, please sign this. And again, those of you who are interested in doing other projects, you can get in touch with Yusuf. He runs the robotics club. Okay, how many of you are undergraduate students? So, and how many of you are mechanical engineering? Okay, so let's stop here for today. Make sure if you haven't ordered the book, you can order it or you can get a copy. But we'll start off with this.